Hello everyone. Today we will learn about mobile point-to-point model or also called Lee model. Why we are finding this mobile point-to-point model? We study this mobile point-to-point model to study about the path loss curve. Here what is meant by path loss curve? Path loss curve means finding the signal loss, how the signal is attenuating or how the signal strength is decreasing due to different human made structures or due to different natural terrain configurations in a particular area. This is so finding out the signal strength in a particular area based on different human made structures due and natural terrain configurations, we will um, study in the form of path loss curve. So to find out the mobile point to point model, we will study three steps. Hello everyone. Today we will learn about mobile point to point model or also called Lee model. This mobile point this mobile point to point model. Hello everyone. Today we will learn about mobile point to point model or also called Lee model. Why we are studying this mobile point to point model means to find out the path loss curve. Here what is meant by path loss curve? Path loss curve means to study the signal loss, how the signal is attenuating, or to study the signal strength in a particular area due to different human made structures or natural terrain configurations. This is about path loss curve. So, to study this path loss curve, or we, hello everyone. Today we will learn about mobile point to point model, or also called Lee model. Why we are studying this mobile point to point model? Because here we will study about path loss curve. Hello everyone. Today we will learn about mobile point to point model or also called Lee model. We are studying this mobile point to point model or Lee model to find out the path loss curve. Here what is meant by path loss curve? Path loss curve means we will study about the signal strength, how the signal strength is attenuating or how the signal is affecting due to different human made structures or due to different natural terrain configurations in a particular area. So to find out the path loss curve, we will go for mobile point to point model or Lee model. This mobile point to point model is obtained in three steps. That is to generate a standard condition, area to area prediction model, and to find out the mobile point to point model using area to area prediction model. These are the three steps we study in this Lee model. So coming to the standard conditions. Here standard conditions means we will in we will have a standard conditions at the base stations and the at the base station and also at the mobile unit. For example, at the base station, I am taking the standard conditions. Standard condition, the transmitted power at the base station is 10 watts. It is the standard value I had taken. Now if I want to change the transmitted power at the base station, that is I want to increase or decrease the transmitted power at the base station, then I will use the correction factor. Here the correction factor is alpha 1. Alpha 1 is equal to 10 log Pt dash by 10. Here Pt dash represents the change in transmitted power. Whether I am increasing or decreasing, the change is represented in Pt dash. And the standard condition at the base station, the height of the antenna height is taken as 30 meters or 100 feet. Now if I want to change the height of the antenna, or if I want to increase the base station antenna so that it covers the more area, then I will go for a correction factor, that is 20 log h1 dash by h1. Here h1 dash represents the change in the antenna height, that is how much I am increasing or decreasing. The change in the antenna height is represented in h1 dash, and the actual height, it is h1, that is 100 feet. And also antenna gain at the base station, the standard condition is taken as 6 dB per dipole. And if I want any correction factor, I will take it as alpha 3 is equal to gt dash minus 6. And similarly, now coming to the mobile unit, I am taking the antenna height as 10 feet or 3 meters. Now if I want to change the antenna height, for example, my mobile is not receiving the signal and I want to move to the terrace to get a good signal. Then here, if I move to the terrace, the height of my mobile unit is changing. Then I will apply the correction factor, that is alpha 4. Alpha 4 is equal to 10 log h2 dash by h2. Here h2 dash represents the change in the height of the mobile unit and h2 is the actual height. The standard condition I had taken here 10 feet. And the antenna gain, it is given as 0 dB per dipole, and the correction factor it is given as gm dash. These are the standard conditions I will take at the base stations or at the mobile unit to find out the path loss curve. So finally, the topic we are studying here is mobile point-to-point model or Lee model. To study the path loss curve. Path loss curve means to study the signal strength in a particular area. Considering the human-made structures and natural terrain configurations. Now coming to the area-to-area prediction model. This area-to-area prediction model is also called as it can be also be said as effect of human-made structures. It can be also told as effect of human-made structures. It means here I am calculating by using the area-to-area prediction model. I am calculating the signal strength in a particular area and how the signal strength is changing due to the human-made structures or terrain configurations around the base station. So here the terrain configurations, see for example in a city or in an area, we will have different terrain configurations or we will have different human-made structures. It changes with an area to area. So at each area, when we are going to calculate a signal strength, the signal strength is affected by different human-made structures or natural terrain configurations. And finally, when we obtain the path loss curve, that is, when we obtain the signal strength in a particular area, we will get different path loss curves in different area due to different human-made structures or natural terrain configurations. So here I am taking here as base station. So base station I am taking, and at the base station I am considering at a circumference of 1 mile, at a distance of 1 mile, and at the 1 mile distance I will consider what are the human made structures, that is what are the buildings or what are the natural terrain configurations. And in this 1 mile area I will take the readings of high spot areas and low spot areas. Here high spot areas means high signal strength areas and low spot areas means low signal strength areas. And similarly, I will take the data at 5 mile, at the distance of 5 miles. I will consider the high spot areas and low spot areas. And at the 10 mile area, I will consider the high spot areas and low spot areas. That is high signal strength areas and low signal strength areas. The signal strength areas changes. We are getting high spot areas and low spot areas. Why we are getting different values, high spot areas and low spot areas? Because of due to human made structures, that is due to different buildings and due to different natural terrain configurations, we are getting these high spot areas and low spot areas. So as at 1 mile, at 5 mile and 10 miles, at different areas, at a different distance, I am considering the path loss curve in a particular area. This is for a particular area base station, not different area. This is particular area base station. I am calculating the high spot areas and low spot areas. After calculating the high spot areas and low spot areas at 1 mile, 5 mile and 10 miles, now I will draw a curve, that is path loss curve. We will draw a path loss curve taking the x-axis representing the distance, that is at taking the readings at 1 mile distance, 5 mile distance and 10 mile distance, and the y-axis represents the signal strength. And at the 1 mile distance, I will note down the high spot areas and low spot areas. At 5 mile distance, I will note down the readings that I had taken the high spot areas and low spot areas. And at the 10 mile distance, I will note down the high spot areas and low spot areas. And now I will calculate the mean value, the average value at 1 mile, average value of these high spots and low spot areas at 1 mile, average value of this high spot and low spot at 5 mile, and average values of high spot and low spot at 10 miles. And finally, I will draw a curve. This curve represents the path loss curve. That is how the signal strength is decreasing due to different human-made structures or natural terrain configurations at a particular area. See here at the 1 mile distance, I am getting the high signal strength. It means as it is near to the base station, I am getting the high signal strength. And as the distance, as I am moving away from the base station up to 10 miles, the signal strength is gradually decreasing. This represents the path loss curve. That is how the signal strength is varying in a particular area due to different human-made structures and natural terrain configurations. This talks about the area to area prediction model. Clear? Now coming to the third step. That is point to point prediction. That is point to point prediction using area to area prediction model. That is to obtain a mobile point to point model using a area to area prediction model. So to find out the point to point model, we use the area to area prediction model. So I am taking area in an area to area prediction model. I am considering two parameters. That is, one is 1 mile intercept point and the second is path loss phenomena or path loss slope. Here 1 mile, what is meant by 1 mile intercept? Here 1 mile intercept means the power received at a distance of 1 mile from base station to the mobile unit. It is the power received at a distance of 1 mile from base station to the mobile unit. This is 1 mile intercept. And considering this 1 mile intercept, I will go for two general approaches. Now, okay, clear? Now we are in this 1 mile intercept point. I am discussing about this 1 mile intercept point. You already know this 1 mile intercept point means the power received at a distance of 1 mile from base station to mobile unit. So in this 1 mile intercept point, I am considering two general approaches. That is, one approach is comparing the area of interest with an area of similar human-made structures as shown in the figure. Comparing the area of interest with an area of similar human-made structures. That is, here I will calculate different path loss curves. Different path loss curves for different cities. These are the standard conditions. That are given. That is, x-axis representing the distance from transmitting antenna, and the y-axis represents the signal strength in dB. Here they had taken the path loss curve. See the path loss curve for New York, the path loss curve for Tokyo, Japan, the path loss curve for Philadelphia, the path loss curve was suburban, the path loss curve for open area and free space. These are the different path loss curves. We already know that we will get different path loss curve for different areas due to different human-made structures and natural terrain configurations. So here we had obtained different path loss curves for different cities, as each city is different from other city due to human-made structures or natural terrain configurations like hilly areas. So here it is given as different path loss curve for different cities. Now at the second case, it was asked that if the human-made structures are different from the cities listed in this graph, that is, if the human-made structures are different compared to the cities in this graph or path loss curve, then how you will calculate the path loss curve at 1 mile intercept point? How you will calculate the path loss curve with 1 mile intercept point? This is like an example in our while studying mathematics in classwork. in notes they will give one example. They will solve one example and they will say us to solve the remaining problems which are similar to that example. Same in that pattern only. Here the standard conditions are given of different path loss curves. Now it was asked if to draw a path loss curve if the human made searches are different from the cities listed here in the graph. Then how we will draw the path loss curve? We already know how to draw the path loss curve. How we will draw the path loss curve? We will take in base station at one point. We will consider base station at the one point, and we will compare the buildings or hilly areas around the base station at a distance of 1 mile, comparing the building heights and other cities with an area of 1 mile. And we will take 6 to 7 data points around that 1 mile intercept point. That is considering the buildings and hilly areas, natural terrain configurations. We will take the data of high spot areas and low spot areas. And similarly, we will continue for 5 miles and 10 mile area. We will take high spot areas and low spot areas. And finally, we will calculate the mean value. We will calculate the mean value of high spot areas and low spot areas at the 1 mile distance, at 5 mile distance, and 10 mile distance. Here it was asked for 1 mile intercept point. So at 1 mile intercept point, I will take 6 to 7 data readings of high spot areas and low spot areas. I will take the mean values of that taken data values, and similarly I will take the data values mean value of the readings taken at the 10 mile distance, and finally I will draw a curve. Finally I will draw the curve which represents the path loss curve. This path loss curve represents how the signal strength is changing due to different human made searches and natural terrain configurations. This is the second general approach. So here we have studied the two general approaches in 1 mile intercept point. This is studying of area to area prediction model. In area to area prediction model, we had studied the 1 mile intercept point. Now coming to the path loss slope or path loss phenomena. Path loss slope or path loss phenomena. While studying this 1 mile intercept point and path loss phenomena, we are in the third step. Remember that while starting the mobile point-to-point model Lee model, we had studied three steps. One is standard condition, second area-to-area prediction model or effect of human-made searches. Next, mobile point-to-point model using the area-to-area prediction model. So to find out the point-to-point model, we had studying the area-to-area prediction model. In this area-to-area prediction model, we had studied 1 mile intercept point and path loss slope or path loss phenomena. So coming to the path loss phenomena or path loss slope. Here path loss phenomena is nothing but we will draw the path loss curves of different areas. We already know that for each area we will get different path loss curve. So at different areas we will draw different path loss curve, and we will we will display all this path loss curve at one place. We will study all these path loss curves of different areas at one step. Then it can be said as path loss phenomena. So coming to the path loss phenomena, see here carefully. For suppose if the area is hilly, then automatically the path loss slope changes, because due to hilly areas the high spot areas and low spot areas changes. The signal strength changes. Now here also you will take the data points to draw the path loss slope. Suppose if the antenna height should be increased due to the presence of hilly area, if the antenna height should be increased to cover the more area in a hilly area, then how to change the antenna height? We had already studied in the standard conditions. In step A, we had already studied the standard conditions. That is at the base station. If I want to change the antenna height, then what is the formula I had the correction factor, what I had used there, 20 log change in antenna height by actual antenna height. So here I am writing the correction factor 20 log Hg by H dash. That is the effective antenna gain. I am getting the effective antenna gain by changing the antenna height with correction factor 20 log Hg dash by H1. That HE is the effective antenna height, that is change in the antenna height due to hilly area, and H1 is the original antenna height. Now again, after getting the standard condition, after applying the correction factors, now I will go to draw the path loss curve by taking the high spot areas and low spot areas. Now in this path loss phenomena with a 1 mile intercept point with the different slope is as shown in the figure. That is, I will consider here three cases. Three cases mean three areas. For example, three areas. In the three areas, how I am getting this path loss curve? See, these three areas. See here in the first area. In the first area, you can observe that near to the antenna, there are more buildings. Near to the antenna, there are more buildings, and far away from the antenna, the height of the buildings are low, and it is an open area near to the similar to the open area. As the at the point of A and B, this you can also take this A and B as mobile units or mobile unit points. At points of A and B, as there are more buildings, the signal strength will be decreased. So here see at y-axis representing the signal strength, the A point and B point are decreased. Signal strength is decreased. And the C point as it is in the open area, similar to open area, but as it is away from the antenna height, here the signal strength is decreased at the point C also. Now coming to the second case, here from the antenna, near to the antenna, it is similar to the open area, that is the heights of buildings are low. And the points A and B are receiving the good signal strength. And coming to the point C, as there are more number of buildings, the signal strength decreases due to these human-made structures. So while drawing the graph, you can observe that the point A is having the high signal strength and point B is also having a good signal strength. But the point C is having the low signal strength due to different human-made structures like buildings. And coming to the third case, here I am taking the buildings are all even buildings. Under three cases A, B, C or three mobile units, I am drawing the path loss curve representing the signal strength at A, B, C. Here the path loss curve is equal to 40 dB, and the points A, B, C, the mobile units or the points A, B, C represents the signal strength or the path loss curve of this mobile units or mobile points A, B, C. Clear? This is about the path loss phenomena. Here path loss phenomena is nothing but we are taking, this is one area which is different from this second area, and these two areas are different from this third area. For these three areas I am getting the three different path loss curves, and all these path loss curves are represented or we are studying at a one table. This studying of all these path loss curves are different areas due to which says different signal strengths due to different human made structures represents the says the path loss phenomena. And the first case and second case, the average values of this first case and second case are taken in this third case, and this represents the path loss phenomena which we studied in the third step, that is point to point model using area to area prediction model. See, this is point to point model, A point, B point, C point, A, B, C or mobile units, A, B, C, 3 points or 3 mobile units, studying point to point model. By this we are studying the Lee model or mobile point to point model. Clear? This is about mobile point to point model or Lee model. So once again briefly, just a minute, in to study why we are studying this mobile point to point model, we are studying this Lee model to draw the path loss curve, to study the path loss curve. Here path loss curve means studying the signal strength, how the signal strength is changing in a particular area due to different human made structures or natural terrain configurations. To study this path loss, to draw a path loss curve, we are going for mobile point to point model. So in this mobile point to point model, we are studying, we will have three steps. The first one is to generate standard conditions. That is standard conditions at the base station and standard conditions at the mobile unit. And for each standard condition, it is transmit power. I am taking 10 watts. And if any correction factor, I am applying 10 log PT dash by 10. And antenna height at the base station, the standard condition is 100 feet. And the correction factor is 20 log H1 dash by H1. And the antenna gain 6 dB per dipole. And correction factor GT dash minus 6. Similarly at the mobile unit, the standard conditions, height of the mobile unit 10 feet. And if I want to apply the correction factor, 10 log H2 dash by H2. And gain 0 dB per dipole and correction factor gm dash. This is the first step. And coming to the second step, area to area prediction model, we are studying it. We also say it as effect of human made structures. In effect of human made structures, we are calculating the path loss curve. To calculate the path loss curve, we are studying here the signal strength, how the signal strength is changing in a particular area due to different human made structures or natural terrain configurations. We already know that due to each area is different from other area, and due to different we will get different path loss curves in different areas or different cities due to different human made structures or natural terrain configurations. So to draw the path loss curve, what we are doing, we are taking one base station at the center, and for that base station at a distance of 1 mile, we are noting high spot areas, low spot areas. Similarly for 5 mile and 10 miles. And we are calculating the mean values of this high spot and low spot areas that representing x-axis distance and y-axis signal strength. And we are getting the curve. This curve is called path loss curve. This is about area to area prediction model. And coming to the point to point prediction model, using area to area prediction model, in this area to area prediction model, we are using two parameters, that is 1 mile intercept point and path loss slope. Here 1 mile intercept point means the power received at a distance of 1 mile from base station to the mobile unit. So in this 1 mile intercept point, we are taking two general approaches. That is, for the first one is comparing the area of interest with the area of human made structures. That is, here it is given the path loss curves of different cities. As each city is different from the other city due to different human made structures, we are getting different path loss curves for different cities. Now in the second approach, it was asked that if the human made structures are different from the path loss curves represented in these cities, then how you will draw the path loss curve at a distance of at a 1 mile intercept point. Then how we will draw the path loss curve? I will take a base station at the center at a 1 mile intercept point. I will note down the high spot areas, low spot areas, and I will take the mean value of this high spot areas and low spot areas, that is high signal strength, low signal strength, and I will draw the graph representing at the 10 mile distance also. By this I will obtain the path loss curve. And coming to the second one, that is the second parameter, that is path loss slope. This path loss slope are also called as path loss phenomena. So to obtain the path loss slope, here it was taken one example. He is taking one example that if the height of the antenna should be increased due to hilly area, so that it to cover the more area, then how to change the antenna height? Then how we will change the antenna height? Just simply we will apply the correction factor. After applying the correction factor, we will study the path loss curve by taking the high signal strength areas and low signal strength areas. And in this path loss phenomena, I am taking the three cases representing how the signal strength is changing at 3 points. At 3 points, that is A, B, C. These 3 points can be represented also in the form of mobile units. That is, at 3 mobile units or 3 points, how the signal strength is changing. In the first case, the A, B points are near to the buildings and the signal strength is low. Signal strength is low due to more number of buildings. The signal strength decreased. And at the point C, as it is away from the antenna, the signal strength is decreased. This represents one path loss curve. And in the second case, the AB points are similar to the open area and it is receiving the more signal strength. That is, A and B are receiving the high signal strength. That is, and signal C, point C is receiving the low signal strength due to human made structures. And the graph is represented. That is path loss curve. See, A and B are near having the high signal strength and C is having the low signal strength. And the third, having the all buildings and at the points of A, B, C, the signal strength, how the signal strength are received at the points of A, B, C, and the path loss curve is represented in in this form. That is A, B, C having the signal strength. It is decreasing gradually as C is away from the antenna. C is having the low signal strength, B is having the medium, and A is somewhat better than the remaining three. And due to this human structures, the signal strength is represented in this form. This path loss curve is represented in this format. This represents the path loss phenomena. Clear? This is about point to point model or mobile point to point model or Lee model. Thank you.